So hi everyone, happy Friday. Welcome to today's episode of SageMaker Fridays. We're going to be talking today about data preparation for machine learning and how you can do it faster, how you can do it at scale with Amazon SageMaker tools. I'm Claire O'Brien Rajkumar. I'm a senior product manager on the SageMaker team here at AWS. I'm joined here also by my colleague Charles.
Thanks, Claire. Hi, everyone. We're excited about SageMaker Fridays today. I'm Charles Laughlin. I'm a ML specialist here at AWS. I've been here nearly 4 years, and myself and colleagues that are in similar positions, we have the high privilege of working with customers every day. First, we listen to their needs, and then we provide them counsel on how to make their AI ambitions turn into realities. Very excited about today. We've got some slides, some demos, and at the tail part of the hour, we have a live question and answers. But I'll turn it back to Claire. Claire can start us out with the full agenda and get us started. Thanks.
Thanks so much, Charles. So talking about listening to our customers' need, we have actually changed up the second half of our agenda. So in order to respond to all of the customer questions that we are hearing around Gen AI. So we'll be spending the second half of this session on a Gen AI use case. But what we'll do is we will start out with an introduction around SageMaker Data Wrangler. So SageMaker Data Wrangler is a visual low-code data preparation tool to help accelerate your data preparation for machine learning. I'll be talking you through an overview of the product, showing you some highlights and features, and then Charles will be going into a hands-on demo using tabular data. We'll be sharing right before this demo a QR code so you can actually follow along with the resources and the data set if you like during this webinar. Second half, we'll pivot to talking about data preparation for Gen AI use cases, and Charles will do a demo showing how you can use Data Wrangler also to prepare data for use in RAG and Gen AI use cases. So here at Amazon SageMaker, we support the end-to-end machine learning workflow. So we have tools all the way from data preparation to model building, training, tuning, and of course, deploying and managing your machine learning projects. We all know that high quality data preparation is critical to high quality model performance, and high quality model performance means better business results. So that's where we're going to be focusing today on the first step of the machine learning workflow, understanding how we can prepare high quality data. Particularly important, we are going to be focused on, as I said, SageMaker Data Wrangler, a low-code data preparation tool. Why we're focusing on a low-code data preparation tool is because we want to show you how you can use this tool to accelerate your typical ML workflow. We hear time and time again from customers that they spend about 80% of any machine learning project on data preparation. So our goal is to help shrink that amount of time spent on data preparation while still preparing the high quality features needed for successful machine learning projects. So with that, let me introduce SageMaker Data Wrangler. So SageMaker Data Wrangler is a feature of SageMaker Studio. Within SageMaker Data Wrangler, you can connect to many different data sources, both native AWS sources like S3, Redshift, Athena, and EMR, as well as third-party data sources like Snowflake and Databricks. Once you've connected to your data, you can use our point-and-click UI to visually explore your data, generating visualizations to understand your data within just a few clicks, and then transforming your data in just a few clicks by selecting any of our 300 plus built-in ML-specific transformations. Once you've built out your data preparation workflow in Data Wrangler, you can then bring that data prep workflow into your training pipeline, into your inference pipelines, or into any of your data pipelines using SageMaker processing jobs, which you can launch either directly from the Data Wrangler UI or you can export a notebook, a SageMaker notebook or Python file with all of the orchestration code needed to bring that into your data and ML pipelines. So a little more on the sources that we support in Data Wrangler. As I said, we cover many AWS sources, S3, Athena, Redshift, and EMR. We have partner sources as well. I also want to call out that we have an integration with Amazon AppFlow. Through this integration with Amazon AppFlow, you can configure access to 40 plus SaaS data sources so that you can access this data directly within Data Wrangler. When it comes to quickly exploring and understanding your data, we have ML-powered analyses that you can configure and launch that you can configure and use in just a few clicks. So looking at this one here, we actually see that these ML-powered analyses can help you understand the quality of your data and determine what steps you need to take to make your data set ready for use in building an ML model. We detect things such as target leakage or skewed target, and also help you understand basic summary statistics of your data. One particularly powerful feature for understanding your data within Data Wrangler is our quick model feature. This is a pre-trained XGBoost model that you can run to directionally understand the quality of a model built on your data set and the feature importance of the different features in your data set. We see that customers really enjoy using this iteratively as they work through their data prep steps. When it comes to transforming your data, we have 300 plus ML-specific transformations. So you can think of ones such as one-hot encoding, dimensionality reduction using PCA, and all of these can be searched from our library of transformations and quickly added to your data prep workflow. For anyone wanting to author their own custom transformations, you have the ability to do so using our custom code editor, and we even offer a library of code snippets to help accelerate the authoring of these custom transformations. Once you have built out your full data prep workflow, as I said, we want to help you bring that data prep flow into your machine learning pipelines, whether it's your development pipeline, your training pipeline, your inference pipeline. And you can do that either by staying within the Data Wrangler UI. You can launch a processing job from our UI. You can schedule that processing job from our UI. You can parameterize the input sources via our UI. But you can also pivot and take a code first approach by using a notebook or a Python file with all of the orchestration code and the data recipe from the visual data prep workflow that you built in Data Wrangler. So with that quick introduction to Data Wrangler, I'll hand it over to Charles to walk you through the basics of Data Wrangler, following a use case around predicting hotel cancellations. As I mentioned before, on this right-hand side, we have a QR code. This will bring you to an online self-paced lab where you can find the data set that Charles will be working with and understand and replicate some of the steps alongside Charles or at a later time. So with that, Charles, I'll hand it over to you.
Thank you, Claire. All right, let's get started. Okay, I'm going to start us out for this demo here at SageMaker Studio. Data Wrangler lives inside of SageMaker Studio as an app. To begin with, what I'll do is, by the way, I went ahead and I downloaded the file from Kaggle and I placed it on S3 for the demo. What I'm going to do to start is kind of show you how to get started with Data Wrangler. You can simply do File, New, and click on Data Wrangler Flow here within inside Studio. And the next thing that we'll do is we need to indicate where our data originates. Now, I know Claire mentioned there are more than 50 kinds of input sources that are available. And for today, and these include the myriad of databases and API endpoints. For today, I'm just going to click on Amazon S3. This is where the data lives for the hotel bookings. And what we can see with Data Wrangler is there's a preview of the first 100 records are shown. So this is the tabular data. This is the way we would expect it to do. There are support for other kinds of inputs, such as multimodal data. Later, we're going to use something with Gen AI, and we're going to use JSON as the input, but also image data and other things are available. Data Wrangler also has this capability that you can do sampling. So maybe you've got 10 million rows of data, and you don't need to work with all 10 million rows of data here. You can turn on sampling, and you can do stratified sampling or a random sample, and so forth. For now, the default here is the first 50,000 rows of data. And so I'm going to just slim this down a little bit further and click on Import. And then it's at this point you can start to build your transformation, helping do the exploratory data analysis and converting it from how it lives now at rest to the way that a binary classification model would be best trained. And of course, you can follow this lab along, from the QR code. You can follow these steps yourself. First thing I'd like to do is actually I'm going to go over to a graphic view where we can see the flow. And Claire mentioned analyses. So the one thing that I'm going to do, I'm just going to do a couple of these kind of from zero, but then I'm going to move over to a completed, a completed flow as well and highlight just a couple key moments in there. Here are some of the analyses that are available. The first one that I would highlight is something called target leakage. And so mainly what I want to do is to find out if there are any data features here that always guide me to the right answer. We want to get rid of those. Now, we have a classification problem. We're trying to identify if the person who made the reservation is going to cancel or not cancel. So we simply point as this is a classification problem, and canceled is the feature we want to look at. So we'll let this run for a second. And we get some feedback here graphically. And what we can see is that there's a high indication here of target leakage in a feature called reservation status. And we'll look at this more a little bit, but the idea here is that these are just an easy way that these analyses help you as an engineer to know more about your data and to help guide you to building a really great model that will train well. So I wanted to highlight that one. Of course, there are many other analyses that are also available for you. As an example, just to show you, Claire had mentioned there is that portfolio of more than 300 built-in transformations. And it's very easy just to go find these. And now that we know that there's a feature called a reservation status, we might want to find out, well, let's drop that column. And so here's a way that you can do this without any code. We have a transformation that can do things like remove duplicates and so forth, but drop column is the right thing that we want to do. And we want to remove that feature that was called reservation status. So it's just as easy to do that, and now without writing any code, that feature is gone, and so forth and so on. So the idea here then is that you can continue to build on and continue to shape the data over a series of ordered operations. But rather than watch me build all of these, what I would show you here is I went ahead and did that lab ahead of time, and I've built all of these transformation steps that it guides you to do. So we can look at the journey of that data from its origin, the natural shape, all the way out through the end state, which we'll build a model from. I will highlight just a couple things because this is really an important how the system makes all this available without writing code. Here, what we're going to do is look at handling outliers. We want to, typically this is something that feature engineers will do, is to remove outliers because they can build a model that may be overfit and doesn't really generalize well. So this is an example of how that works. Within Data Wrangler, there are different kinds of outliers that we support. For this one, what I'll use is a standard deviation-based outlier. You simply point the one or multiple numeric features that you want to have the treatment. And then for every feature, Data Wrangler will compute the mean and the standard deviation for those features. And then we can specify where is the outlier point. So typically 3 standard deviations is something that captures, generally 99.5, 99.7% of your variety. Definitely anything outside of 4 standard deviations it would be an outlier. And then moving forward, some other things that are helpful is to scale data. So in this data, we have the price of a room, which can be hundreds of dollars. And then we've got other features which operate on a basis of 0 to 1. So this is a scaling technique, which is very useful, and where we develop the min and max range for every feature. And the importance of this is it makes every feature be treated the same. So something that has a natural value of in the hundreds or thousands gets treated equally weighted to something that is something on a scale of 0 to 1. So here what we do is we specify all the features we want to scale. We specify where is the bottom of the scale and the top of the scale, and the system will automatically do that. So this now makes all of these features, regardless of how they started, they all operate on a basis of 0 to 1. And then final thing that I would show you here in terms of transforms is the ability when you're building classification models. It's very important that you have equal class representation in those models. And so this is a way that Data Wrangler is able to do this for you without writing code. We have different methods of rebalancing the data. And so these include SMOTE, they include randomly oversampling the underrepresented class, or we want to upsample the underrepresented class. And the idea here is that our feature, our target is canceled, and let's say that mostly let's have the desired value of 1. So we want to have equal representation. If you have other ideas in mind, other ratios are supported. So within a few minutes, this isn't weeks or months. This is within a few minutes. You can build these transforms, and you'll see this by going through the lab. And then the last thing I would want to show you here is this. This is called a data quality and insights report. And what this does is before you spend time to send this data over to your training module, as with SageMaker Canvas, what you can do here is to actually get kind of a preview if that model is going to be performing well or not. If there are still problems with the data, you can find that here inside the Data Quality and Insights report. And then you can iterate and do corrective measures here versus sending that data off to a training module and then find out that after you spent the time training that maybe there were results not as expected. So I'll give this just a couple seconds to finish up, and there'll be a lot of metadata that we'll look through. Okay, this is completed. This may take a minute or two in your own experience, but what Data Wrangler will do here is provide a rich set of data that you can read through and determine, is it time to make that investment to do a model training? We start by some summary statistics about the data up top. And then we also call out here, any kind of high priority items that need to be remedied. Now, keep in mind here, it's mentioning that we have duplicate rows, and it actually shows us these duplicate rows. And actually, this is expected here because we did that oversampling of the underrepresented class. We needed the class balance. So because of that, I'm aware of this, and this does not cause concern. Next, what we do are call out anomalies in the data. So these are items which have high or low values, that kind of don't fit what's expected for the binary class. Another way to look at the data here is we've seen that we've balanced the data, so there's an equal representation of zeros and ones, or cancel and not cancel, as it were. And then this is a very important item here, maybe one of the most important ones you might see. What this would show you is the accuracy of the model. And we use, Claire mentioned this earlier, but we do use an XGBoost model for training. A Data Wrangler splits the data, as it says here, into 80-20 ratios and develops these predictions in the blind. In our training data set, we have about a 91% accuracy. And in the validation set in the blind, we also have an 86.7% accuracy level. So these aren't too far apart. And this actually looks good. So if these numbers are not to your tolerance, you might continue to iterate. In addition to that, there's also a confusion matrix, which will help you see kind of the distribution of true positives and true negatives and so forth. And then the last thing I would call out is important here is the feature importance. So what you can see here are, for all the features you provided, this will actually let you know how helpful they are, the strength of that. So, in terms of avoiding, maybe cancellations. So I won't call out all of these, but I'll just mention lead time. What this would tell you is that the greater the lead time, the less likelihood it is that people will cancel. Or stated differently, if people are booking at the last minute, maybe that means that that they also may be more likely to cancel, and so forth and so on. So as an organization, you might use this to understand what are the things that drive the outcomes, and you might understand how to move those levers to influence people to, be loyal, or maybe maintain that. In this case, maintain that booking. There's plenty of other detail that here. We definitely hope that you go through the lab and look at this. All of it, there's lots of rich detail for every one of the features. I don't have time to show them for you now, but I hope this is helpful, and I hope this shows in just a few minutes we have been able to take raw data, public source data, and we've able to reshape it without writing any code and build a model that looks like it's about 85 or 90% accurate for the business case at hand. Hope this has been helpful. This wraps up this part of the demo, and I'll turn it back over to my colleague Claire, where we'll move over to the next part. Thanks.
Thanks so much, Charles. I wanted to jump back in here. Charles walked us through a tabular data sample just right now, but I wanted to take a moment to call out two other features of Data Wrangler that he didn't get a chance to touch on. So first is support for image data. So we recently added support for image data within Data Wrangler. You can see here the ability to import and preview a set of image from an S3 data source. And we also offer all of the common built-in transformations for folks who want to use image data for CV use cases. This includes things such as, typical cleaning transformations, dropping duplicates, dropping corrupted images, augmentation transformations such as blurring, enhancing contrast, etc. The other feature that I wanted to touch on that is our data prep widget. So the SageMaker Data Wrangler data prep widget is a data prep widget that lives in Studio Notebooks. So we learned that while many customers want to use our full Data Wrangler data prep app, there are actually several customers who enjoy the notebook experience and just want to move faster while remaining in the notebooks environment. So to meet those customers where they like to be in notebooks, we brought out the SageMaker Data Wrangler data prep widget. Within Studio Notebooks, you can import the Data Wrangler data prep widget. It'll offer you column level visualizations of your data frame in Studio Notebooks. And what it will also do is, one, flag data quality issues that it detects in your data. You can see in this image here, small exclamation points, little warning signs at the top of different columns. And then it will suggest transformations to remediate these issues and prepare your data set for your ML project. If you want to use these suggested transformations, all you need to do is one-click apply. The code to to transform and manipulate the data will be generated and added to your notebook workflow. So just wanted to make sure that users were aware of these two additional features of Data Wrangler. And with that, I will move into the second part of today's session, talking about data prep for Gen AI use cases. So where data prep for Gen AI use cases comes in is when users want to fine-tune their models. So fine-tuning your models is really about customizing model outputs for your organization. So there are several reasons why you would want to use this, and you're probably familiar with them. Firstly, it improves domain relevancy if you fine-tune the model on your organization's data. Secondly, it helps mitigate some of the risks that we've heard about in using these large foundation models and taking advantage of their generative capabilities, such as non-compliance, toxicity, and potentially even hallucination. So by fine-tuning the model using your organization's data, we can greatly reduce the risk of these experiences with foundation models. And then lastly, some users and some customers can actually improve model performance and cost by fine-tuning the model. So with that, I will turn it over to Charles, who will talk about a specific data preparation technique for customizing model outputs called RAG, or Retrieval Augmented Generation.
Hey, thanks, Claire. Maybe before I jump in, maybe if you could just spend a second to define that term, that acronym RAG, for the audience who might not have heard it.
So RAG, as Charles said, stands for Retrieval Augmented Generation. Essentially, in these cases, organizations augment the output of foundation models, so the response from a model with information from their company's corpus of data. So by augmenting the response from the model, they can achieve a few things. So one, they can achieve more accurate and more robust answers from their model. And then two, we all know it's impossible to keep these models trained on the most up to date real time information at any point in time. So by using the RAG method, we can actually augment model responses with more up to date company data and information, even if there has been a gap of time since the model has been retrained. So back to you, Charles.
Great. Thanks, Claire. That's very useful and good insight. So what I'd like to do now is to lead the audience through a couple slides to kind of describe the use case, and then I'll cover the architecture, and then finally we'll move over to the console, and we'll see this in action with a demo. So to begin with, what we're going to do today is we're going to use an open source data set that has wine information, and in fact this comes from Kaggle. And think about today for our use case, we're going to demonstrate the ability to kind of build a chat application. So here you've got a chat application where a consumer can ask a question, a wine that pairs well with beef. And then this is an example of the answers that come back from the foundation model without fine tuning. Now, the nice thing is that the model actually maybe does a good job. These look like valid answers that come back. But in terms of the non-compliance and the toxicity and the hallucinations that Claire had introduced, the risk here could be that while that Syrah is a great wine with beef, maybe you as a company don't sell that 2011 bottle. Or on the Pinot Noir, maybe that doesn't give enough descriptive information. And so the idea is that you want to have these things tailored to your standards. On the next slide, what we'll walk you through is the example as an organization, how you would improve and go about the journey to improve. So what you start out with doing is developing your requirements. So what is it that you want your chat application to say back to your internal customer service teams or to your public? You start out by saying, well, first of all, let's make sure that whatever it says back on this wine application, it's a bottle that we sell, and it's a bottle that we maybe have in stock. You might want to mention some technical merits of the product, such as, the style of grape, maybe the flavor profile or winery, country of origin. And you also might want to provide some factual data, like the rating of the wine. And if you translate this to your own company's data, your own products and services that you feature, you might think about the facts that you would want to communicate. Things such as price, things such as nutrition, allergens, and so forth and so on. So after you go through the process of fine-tuning, this is an example of what a good tailored response would look like, one that embodies your corporate standards. So here what you can see is the response comes back and it's factual, it's a product that you sell, and it provides some technical attributes and some true facts, such as the wine rating. And this is an example of what good looks like and what you would then send back as responses to your internal teams or, again, to that external consuming public. Now that we've looked at the use case, I'd like to move next to show you the architecture. And then, again, we do have a demo just ahead. So here what we do is we illustrate one method that helps prepare data for your own generative AI use cases inside your organization. I'll guide your eyes here to the bottom center where we'll look at Amazon SageMaker Data Wrangler. Data Wrangler is going to be the orchestration tool. Data Wrangler will help convert data from the way it lives naturally at rest to the way that a generative AI application would need to consume it. Now, data preparation is going to be absolutely necessary for accurate and contextually correct answers with low latency. To the left of Data Wrangler in this diagram, we see that it consumes input data from Amazon S3. That's our simple storage service, our object store. And while we do show S3 in this diagram, you could easily replace S3 with the more than 50 data sources and diverse data types that Claire had highlighted earlier. And in your own application, that input source might be your product catalog, it might be your customer service knowledge base. Practically, the input here could be any data set that your organization uses. And this is where you should consider the art of possible. But now that I've talked about the data source, I'd like to move now to talk about the data preparation steps. And Data Wrangler accomplishes this in 2 consecutive steps. First, Data Wrangler makes an API call to a SageMaker hosted foundation model. In this case, I illustrate a specific vector embedding model. And vectors are important because they effectively help find information, relevant information. And so instead of looking for exact keywords, there's more of a shift to a conceptual or a semantic search. So take our wine recommendation demo, for example. The vector might consider words like beef or ribeye or steak to be relatively similar to one another. So when the user makes a statement or asks the question for a wine that pairs well with red meat, the language model can better understand and interpret the user's intention. And this is very powerful because what it does is shift the focus onto concepts, to word concepts and themes, instead of specific words. In short, what this does is help users find information, even though their own unique vocabulary or the word choice of the moment may slightly vary. And then next, what Data Wrangler does, secondly, is to make an API call to Amazon OpenSearch service. OpenSearch, it's a fully managed service that, in this example, acts as both a database and a vector matching engine. Data Wrangler is going to place the results of the vector embedding from step 1, along with parts of the original source document, and it's going to store them both in OpenSearch at step 2. And by co-locating the vector along with the original document together, what that means is that customers are able to locate relevant information and to get document content all from a single application call. OpenSearch can help store and search billions of vector embeddings with thousands of dimensions in milliseconds. And best of all, because it's a fully managed service, what that means is customers can spend more time focusing on AI and creating business value instead of spending valuable time managing database servers. In the last slide, we covered data preparation for Gen AI. So imagine now that we have an OpenSearch index and it's been hydrated with your organization's unique data for the use case. In this slide, what we're going to do is to talk about how you can consume that data from a myriad of front-end Gen AI applications. So let's start at the bottom center here with the Amazon SageMaker notebook. Today I'll be using the notebook as part of the demo, but in reality, what this would be AI capabilities that you embed directly into your organization's applications, websites, chatbots, mobile apps, and so forth. And in the context of a chat application specifically, the app should first capture some sort of statement or a question from the user. So sticking with our wine demo that we had talked about, we might make a statement like, I would want a wine that pairs well with beef. So here's how that works. Here's what would happen next. First, the application would take that statement, a wine that pairs well with beef, it'll convert that plain text statement into a vector using the vector embedding model. Now, I want to make a note here. It's going to be very important that same vector model used in the earlier data prep step be the same model that's used for the consuming application. That way, the two parts fit together well. And then secondly, the application, once it's got the vector in hand, will send the vector over to the vector store and ask the vector store, in this case OpenSearch, to find the closest matching documents that have been approved and vetted by your business or your organization. And then finally, the application makes a call out to a large language model. And here we've got a Falcon 7B model. It's a text generation model. And it's going to be responsible for generating the response back to the original question or the original statement at hand. Now, a real important thing here is that the idea is that this response, it's going to represent you. So it needs to be factual. It needs to be contextually relevant. And again, it needs to be one that really embodies your organization's high standards.
Hey, Charles, before you jump into the demo, I just wanted to ask, how did you choose the Falcon 7B model, and are there other alternatives that customers could consider?
Good question. There are definitely alternatives. I think I'll lead off by saying that customers can really choose any suitable large language model. Falcon, I chose this one for the demo. It's a new model, and it's a very powerful, and it's an open source model, which means customers can use it for commercial purposes without royalties. And also importantly, Falcon is something that customers can fine tune. So while we're talking about RAG today, to give up to the minute trainings, this is something that customers can incrementally train and deploy. And then to answer maybe some question about other options to Falcon, we offer several foundation models here from other third-party providers. Now, this is not going to be inclusive, but it's fully inclusive. But it would include partners like AI21 Labs, Cohere, Anthropic, and also many foundation models are available from Hugging Face within your AWS ecosystem.
Awesome, thanks, Charles. So yeah, we can go ahead and get into the demo.
Okay, what I'm looking at here is a Kaggle. This is the open source data set that we'll be working with. There's about 130,000 rows of data here, effectively a tabular data set that describes attributes of wines. Namely, there's the description of the wine, and then other features like the price and the points and the origin and so forth and so on. So I'll start out with in Data Wrangler here, the short journey to take that data from the way it lives naturally at rest into a way that the Gen AI model would want to consume it. First here in Data Wrangler, we're looking at the flow, which we start with the source of the data, which happens to be, I've already pulled that data down from Kaggle. It's a JSON data file, and I've stored that data file here on S3. And then we've got just a few short hops over to being able to store that data in OpenSearch. And so, for example, here, if I double click here inside of Data Wrangler, we're able to see, I've got just a preview here, the first 5 rows of data. There are 130,000, but just the first few rows just to kind of give me a window into what the data looks like. And so here, what Data Wrangler does is open up that JSON body on S3 and then cast it here in the application. We can see it ends with all these facts, these tabular data about the model. Now, what I'll do next is to generate the embeddings. We talked about this as the first step that Data Wrangler will do. In fact, there's just a few lines of code. So here I've got 30 lines of code where I'm actually able to take the original text description, and we're able to convert that text description into an embedding, and using the Bloom model. And here's what that looks like. So originally we have our description. And then over further now, we've got a brand new feature, a brand new column in our data frame, which is the embedding itself. Now, this specific model produces 4,096 dimensions for every string that's submitted to it. And they're not all shown here, but here's a glimpse of what this embedding looks like. And then the second thing that we'll do here, there's the Data Wrangler container itself. It needs the dependencies for OpenSearch to be installed. And there's just a few lines of code here that can do that. We're effectively saying, go out to the operating system and install the OpenSearch library. And so that's just a mechanism there that will do that. And then finally, we're at OpenSearch itself, where again, with just a few lines of code, we're able to take inside the data frame, we're able to take the features like the embedding value that came from the Bloom model, and then other tabular features from the model. From the data, we're able to take these and submit them up and use this function here called OpenSearch Store. And what we'll do there is we'll actually take these features and we'll post them to the OpenSearch index. It's as simple as that. OpenSearch will return back an ID, and then we'll save that ID as a new feature in this tabular data frame. So if I scroll over here to the right, what we see is we have the embedding produced by the prior step one, and then we actually have this kind of confirmation token back from OpenSearch that shows that the data was indexed. So now that we've placed these facts about the wines, and I've went ahead of time, and again, there's 130,000 rows. I've went ahead and did these ahead of time before the demo. But what I'd like to do next is move over to the next part of the demo, and I'll show you how you begin to consume that data from a calling application. Okay, what we're looking at now is I'm inside of a Jupyter notebook. This is a SageMaker hosted notebook, and first I want to open up by showing you the kind of the holistic architecture here. So this looks at the end-to-end. So we talked about earlier, and we just showed the demo of this, how to prepare data with Data Wrangler, and that's actually going to hydrate and deposit data here into OpenSearch service. And then you might think about a way that you would schedule this task to happen, maybe daily, maybe hourly, just depending on your organizational needs. But the idea is that you want to have fresh and relevant data available to serve with your Gen AI application. So you would schedule this to run periodically. And then what I'm about to show you now, although we're using the notebook, this would be any of your own custom applications. And what that will do is to actually go through that series of steps to enrich the data and do that fine tuning. And this is all done in real time. So we'll start here by asking a question or making a statement. And that actually is going to be that we're going to look for a wine that pairs well with red meat. And what I'll do first is submit that over to the Falcon model. And it does return back something that, by the way, this is without fine-tuning. So in this case, what we do is we see that the notebook is just interacting only with the Falcon V model. It's not taking advantage of OpenSearch service or the embeddings that we talked about for fine-tuning. Now here's the example of the answer that comes back. It recommends a wine, but again, the concern here is this may not be factual. It may not be a wine that you offer, and of course, I'm talking about wine, but substitute this for your own product catalog or your own services. So that's an example of what the natural recommendations come back with. You can make a lot of these, and you'll get different, a variety of answers that come back. Again, it knows we're talking about, something that pairs well with red meat, but let's next move into how we start to do the fine tuning. So the first thing I would like to show you, you don't need to do this, but I just wanted to be transparent and show you that we can take this string, the wine that pairs well with red meat, and we can embed that here. So what we're doing is passing that string to a function that was built, and it returns back the embedding, and we can show that the length of that embedding is 4,096 dimensions. And then I'm not needing to see all of these, but I just wanted to show you what these look like. The first 5 of them are being shown. And the idea is that these allow similarity or dissimilarity to be found, and moving more, like I mentioned earlier, to concepts and themes versus literal words. And then the next thing that I would highlight here is let's actually show what's happening in real time. So this is going to be an example of how you build the fine-tuned response. And we'll use a technique called few-shot prompt engineering to achieve this. So here, what we're about to do, by the way, this is an example of the desired output. We want it to say something that looks like this. We want to maybe come back and say that this is from a sommelier and has this recommendation. We want to give attributes like the winery name, the origin of the country, the flavor profile, and so forth. So what's going to happen here in real time, even though we're going to do this right here, but what's going to happen in real time, this notebook is going to first make the call to the embedding model and get the vector, like is shown here. The next thing it's going to do is to go to OpenSearch and find the relevant documents that best meet the criteria. And then finally, it's going to take that recommendation in hand, and it's going to use that context. It's going to use that retrieved context, that augmented context, to go out and then shape a better response back that's been guided through few prompt engineering. So here's what that would look like. And here we go. So we've got back a recommendation. You can see this conforms to our golden model example here, right? So it starts out with I have a wonderful wine for you. We actually talk about the kind of grape. We mention where it's from in the country, and we can also see the number of points as well. So this is just one example, and maybe we could, if the customer turns that one down, we can ask for another recommendation to come back. And so forth and so on. But that's the end of this part of the demo, where we've showed you kind of end to end how to move from a naive response here that maybe doesn't conform to your organizational standards, and then producing a real time, a better response back that does meet with your standards.
Hey, Charles, before we wrap up this demo, can you just tell me a little bit more about how the prompt engineering was done here?
Oh, yes, I can do that. There's a little bit of code up here, for the to help prepare it. So effectively what we would do is we have to show a language model examples of a corpus of information, and then how it would reshape that corpus of information to meet the desired goal. So an example here is, and by the way, there are terms out there if you want to look for an audience to look these up, at zero shot, one shot, and few shot. So what I have here is a few examples, and recommendation, 4 of them examples. And this would show the original document that's stored in OpenSearch. So it's the description and then all these other JSON values. So for example, the number of points is a specific field. And so we show the example of the original document, but we also show how the language model should reshape and provide an output. So you can see these all have that I have a wonderful wine for you, guide. And then from there, what we're doing is we're taking fielded data in the original document, like the number of points, and we're reshaping that into a sentence that restructures it into 85 points. Or on this next one, 88 points would look like that as 88 points, and so forth and so on. And then that's how what we do is we describe the goal. We describe some examples of what good looks like, and then we take the document in hand for the one that meets the utterances just mentioned, like the wine that pairs well with red meat. And then here we leave it empty, and that's where the language model will go out and reshape this recommendation into a clean, brand new, novel recommendation based on these responses. Hope that was helpful for some of our audience.
Yeah, very helpful. Thanks so much, Charles. Now that we've wrapped up the demo, and we've been able to walk you through Data Wrangler, and show you what that tool looks like, and we've been able to walk you through this Gen AI use case. I think that we are at the time for this session. Of course, we want to leave a little bit of time for Q&A with the folks who have joined us live today. Before we jump into Q&A, I wanted to share 2 resources with you. On the left-hand side, we have that Data Wrangler self-paced lab that Charles walked you through in the first half of this session. And then on the right-hand side here, we have a link to our other SageMaker Fridays episodes. I want to specifically point you to the 825 episode that we had on last month. Here we talk about using Data Wrangler in the context of end-to-end low-code ML. So you'll see a lot of the same concepts explored in Data Wrangler that we talked about here today, but you'll learn more about the other low-code, no-code tools within the SageMaker suite of products, and how you can use the data that you prepared in Data Wrangler and then continue in your ML journey, building your models, deploying your models in low-code, no-code fashion. So for folks who want to move beyond data preparation into the next steps, definitely check out that episode. So thank you so much for having us today, and happy to take some questions.